Hey, so today I'm going to talk about how working with variadic templates in C++ is a lot like pattern matching with linked lists, especially in functional programming languages. There's a lot of similarities here, so let's get started. For starters, we have a pretty basic example of how you can create a function that takes in a list of different types, and you just print them all to see out. Now notice we sort of perform pattern matching here. We take the first element of the parameter pack and we sort of decouple it from the rest, and then we print out the head of the list, and if the tail has positive size, like basically if it's not empty, we recursively perform the same thing on the rest of the list. And as you can see, we can just print out a variety of different objects of different types here, and it all works out. And we're able to put a space in between each one with this feature. Now, there actually is a sort of a more idiomatic way to do this, but it has some drawbacks, and that's using a fold expression. So here, not only do we use a fold expression, but we also allow the user to pass in their own output stream. Now, notice that fold expressions and basically I guess the fold or reduce function is pretty common in functional programming as well, working with linked lists especially, and it's also present here. So basically my point is, a good way to think about working with variadic templates is to think of them as linked lists because they share a very similar interface. However, you're computing values at compile time rather than at runtime, obviously, but the main similarity is that you can sort of destructure the linked list into a head and the rest of the list and call it a tail. And it's also hard to access the end of a variadic template parameter pack in the same way that it's hard to access the end of a linked list, a singly linked list.